Good morning, my dear students. In our previous video, we discussed about electric field. As you know, electric field is a vector quantity. It is having both magnitude and direction. The magnitude of strength of electric field is depending on certain factors. It is depending on the quantity of source charge, and also it is depending on the distance between source charge and at that location where we are interested to calculate electric field. As you know, distance increases, the electric field go on decreasing. As the distance reduces, the electric field go on increasing, because electric field and distance both are inversely proportional to each other. And since electric field is a vector quantity, it is having direction also. The direction of electric field is the direction of force experienced by unit positive charge. All these discussion we have done in previous video. Okay. Now, to understand electric field in a better way, the electric field lines were introduced. Okay, and these electric field lines are not physically real. Okay, they are imaginary lines, but they represent a physical quantity which is a real quantity, that is electric field. Okay, so let us start electric field lines and the properties of electric field lines. Electric field lines. These electric field line concept was first introduced by Faraday. Faraday. Okay. And these electric field lines are just pictorial representation of electric field. These are pictorial representation of electric field. In the form of lines. Okay. So these electric field lines are not real quantities, they are just imaginary lines, but they represent a physical quantity, that is electric field, which is a real quantity, which is measurable quantity. Okay. Electric field lines are imaginary, but they represent electric field which is real. Okay. So to understand electric field lines in a better way, we shall start the properties. Okay. Properties of electric field lines. So the first property is the electric field lines, they start at positive charge and they terminate at negative charge. That is the first property. Starts at positive charge and terminates at negative charge. For example, consider this is a line. This is electric field line. It means at this point this line is started by a positive charge, and here the field line is terminated, therefore at this location negative charge is located. This is the meaning of first property. They start at positive and terminate at negative. If I write a only positive charge, okay, it's a single charge, then the field line will continuous till infinity. Okay, if in between no charge comes into existence, then the field line will continuously go on till infinity. For single charge, if I consider negative charge, then the field line will come from infinity and terminates at negative charge. Okay, for a single charge I am speaking. Otherwise, if I write a field line this way, It means that at this location there is a negative charge, therefore then and then only then the electric field line is terminated, and at this point positive charge is located, therefore the electric field line is started or it is initiated. Okay. Okay, second property, electric field lines are actually imaginary lines, but they represent a quantity, that is electric field, which is real quantity. Field lines are imaginary, but they represent electric field which is real. Okay. And the third property, tangent drawn on any field line, indicates the direction of electric field at that location. Consider here, these are electric field lines. Okay, uniform or non-uniform, that is secondary, but consider these are electric field lines. Here positive charge and here negative charge, positive, negative, positive, negative. At this point I will draw a tangent. This is tangent. This tangent indicates the direction of electric field at this point. If I write a tangent here, this is the direction of electric field. If I draw the direction here or tangent here, this is the direction of electric field. At any point on the line tangent is drawn, then that indicates the direction of electric field. This is the third property of electric field line, very important property also. The tangent on line, okay, indicates the direction of electric field. And the next, fourth property, electric field lines never intersect each other. See here, this is an electric field line. One more electric field line I will draw this way. Okay, as according to the third property, tangent drawn on any field line indicates the direction of electric field at that location. Okay, it means I will draw a tangent at this point this way. This is tangent on line A. Okay, and this is the direction of electric field. And for B also I will draw a tangent at the same point, then this is the direction of electric field. At a single point the electric field has two directions, which is not possible in reality. Okay, at a single point two directions is not possible. Therefore two electric field lines never intersect each other, because if they do so, the electric field will have two directions at a single point, which is not possible. Okay, sometimes reason is been asked in your theory examination, therefore it is important reason. If they do so, electric field will have two directions at a single point. Which is not possible. Okay, so this is the fourth property. Next, fifth property, electric field lines never form closed loops. It means like this. If this is closed loop, then the starting point and the end point is same. Okay, but according to the first property, the electric field lines start at positive and terminate at negative. It means the starting point, if I consider it as positive, then the end point has to be negative. But for a closed loop, starting point and end point both are going to be same. Therefore, the electric field lines never forms closed loop. Okay, this is fifth property. Next, sixth property, they do not pass through conductors. This is also very important property. See here, why electric field lines do not pass through conductors. Sometimes this will appear in your annual examination also. I consider a electric field here. Okay, external electric field, positive charges and negative charges. No need to draw electric field lines here. Okay, from positive to negative there will be electric field lines. These are imaginary lines. Physically we cannot see those electric field lines. Okay, and I place a conductor here in between external electric field. The net charge of this conductor initially is 0. Net charge is equal to 0 initially. Okay, it means the number of positive charges and the number of negative charges are equal. Once if I place a conductor in the external electric field, okay, all the negative charges are attracted towards the positive end and all the positive charges are repelled due to the repulsive force created by electric field and they are settled at other end. Okay, and you know, from positive to negative there will be electric field. Okay, one electric field is created inside the conductor and now from positive to negative electric field will be there. And this is electric field. Oh sorry, from positive electric field start and at negative electric field terminates. From positive electric field start and at negative it stops. Positive to negative. This way the electric field created inside the conductor cancels the external electric field. Okay, therefore these electric field lines never pass through the conductor. They can come till this way. Okay, inside they cannot enter since the electric field set up inside the conductor. Okay, so this is very important property, sixth property, why electric field lines never pass through conductor, because the electric field created inside the conductor cancels the external electric field. Understood? Okay, next property, seventh one, they contract longitudinally to explain okay attraction between unlike charges. For example, imagine this is a positive charge, this is negative charge. Okay, these two unlike charges, they attract each other, therefore this length will reduce. Length decreases means they contract each other longitudinally. That indicates what? Attraction. If the length decreases, then the force is said to be attraction. Okay, that is seventh property. And eighth property, they exert lateral pressure to explain repulsion between two charges. What kind of charges? Same charges. Between two same charges. For example, see here, if this is positive charge, this is positive charge, both are like charges. Okay, electric field line will go this way and electric field will radially outward. Okay, and these two cannot meet other. therefore they exert pressure laterally and they travel this way, okay. Due to repulsion, okay, there is repulsion between these two charges, therefore the electric field line come closer and they do not come in contact, they exert pressure laterally and they travel this way. This indicates what? Repulsion. They are repulsing transversely, okay, transverse repulsion, okay. So this property is 8th property, and 7th and 8th property, both these properties explain attraction as well as repulsion between charges, okay. So these are some of the important properties of electric field lines, okay, you can note down. Okay, next property, ninth property, crowding of lines or density of field lines. Density of field lines represents the strength of electric field or the magnitude of strength of electric field. If more number of electric field lines, okay, pass through a cross sectional area, then the electric field is strong, okay. If the crowding is very weak, then the electric field is weak. For example, see here, these are electric field lines, okay. Consider a cross sectional area, unit cross sectional area, and one more type of electric field lines, okay, and consider same cross sectional area, unit cross sectional area, okay. Here two electric field lines are crossing through this cross sectional area, and here 1 2 3 4 electric field lines are crossing through this cross sectional area. It means at this point electric field is strong and here it is weak, okay. And in these two are both are uniform electric field. This is also electric field uniform and this is also uniform electric field, okay. But here the stronger electric field and here it is weaker electric field, because the density is less here, the density is more here. Understood? And last property, okay, in a charge free region, electric field lines are continuous. In a charge free region means if no charge comes in between, then the charge will continue till what distance? Till infinity. That is, in a charge free region electric field lines are continuous, okay. So these are some of the important properties of electric field lines, okay. Now we shall discuss the electric field lines for different types of configuration of charges, okay. Electric field lines for different configuration, for different charge configuration. See, for positive charge, okay, the electric field lines will be radially outward. If this is charge, if I place here a positive charge, due to repulsion the direction of electric field will be in this direction. If I place a charge here, okay, due to repulsion once again the charge will move in this direction. This is the direction of electric field, okay. Around this charge the electric field will be there, therefore it is radially outward, okay. If I consider negative charge, then the direction will be inward, like this. Radially inward and radially outward. Radially outward for positive charge and radially inward for negative charge. Okay. Consider two positive charges, two similar charges. Positive and positive. Okay. So electric field line will come radially outward, but they cannot meet. Okay. They will move this way due to repulsion, like this. And electric field lines should not touch each other, because according to the properties of electric field lines, they never intersect each other. Okay, so this is for similar charges. And one more case, if I consider one positive and one negative, okay, then the direction will be like this. Electric field line start at positive and terminate at negative. Like this. Okay, so this is the electric field line representation for positive and negative charges. And for negative charge, negative. Okay. Electric field lines are directing towards the negative charge. Sorry. All these negative charges are okay. So repulsion, attraction, and radially inward, radially outward. So these are the electric field lines for different types of configuration.